Okay, this is now the session where we wanted to run through the modeling of a simple box culvert, so that you guys can quickly look at and you start from there. I know you are very eager to do that. So once you open the Midas, you go and do the new you make sure you start a new page. Once you do the new page, first thing is you have to go to properties. From properties, you have to do materials definition. Now that we are dealing with concrete, you go to concrete, and then you open maybe a class. Maybe we are using Eurocode, so it is a cylinder strength of 30, and then the compressive of 37. But normally we do 30 to maybe 40 as the for concrete, for bridges and the rest of it. So once you have identified that, you have now defined your material property and you know what to do. So you specify this and then you apply. Once you apply, I think being an integral member, both the vertical wall, top slab, bottom slab, all will be same grade. So we'll leave it at that. For sections, if you were doing some piling or some beams, you would come and add your sections here. You go to concrete and do it. But for this case, we are dealing with the thickness, so we will do that. But for now, we are going to do a wizard, which makes it easier for you to handle. So I think once you specify this concrete, we can leave it at this, and then I go to the structure. From the structure, I come to the RC frame and box. This one I showed you already. On this one, you are able now to come. There's a normal type frame. There's PI type frame. That's how it looks. This is the normal one. Now this is the bridge culvert. This is how it looks, and then it has foundations, separate foundations. Then you have this structure here, integral structure, and then you have the box culvert. Now once you checked the box, the grade of concrete is already here highlighted. Now a single span, it will be from the center of external wall to the center of the other wall. So for these purposes, I can actually say 5.5. And then skew angle, our box is considered 0 or 90. It's not skew, it's just a rectangle. So we don't need to do it. Now it is now here where you highlight the thicknesses are all given up here. The top slab thickness is T1, maybe it is 0.5. Then the bottom slab is T4. Then you look for T4. You get T4 is here. That's also 0. Maybe you can start 0.5. Then what about the thickness? External wall is T3. You look for T3, and then you are able to apply. Put where your T3 is. It is here. It is 0.5 or so, and then from your analysis, you should be able to know the minimum. Then when you do design and it's failing, then you go back and work on it. So we go to T2 is the interior. Interior, we could put 0.3 to start with. So T2 is 0.3. It's not there because it's on the single span, so it's already deactivated. So now I go to the orange. Orange, maybe for now we can do a 0.3. Orange has the benefit of providing more stiffness on your structure. By the way, it's not only for what a fill of material. H2, I could say maybe one. I know it was 8. It was 817, 0.82. Then H3 is okay, that is now the top. Last time I showed you the wing wall is the upward, so you can see this is, I can say, let's say for now I can put 1, or we can put 2, and then we have H1, it's being 5, and then top one, so it is 5.5, and then H2 I've given 0.8, and then H3 I've given you 2, and then P, the thickness of P seem to be the structure, so maybe that is I may put 0.3. we shall be finding out this in our geometry of the road to understand. B4 is now the length. Let me give you maybe 5. So this is now what you do, but you will have picked from your geometry of the culvert. Then B1 is basically the orange. I think this was 0.3. Now this is what you have done to define your box. Then you go to transverse the length. What is the length? That's why you need to know the road width. So the road width is very, very important to understand. And the plate size is already given here. If you want more refined, you can do 0 point. So here I can adopt, maybe we can use 18. And then you see now the spring constant is already given for you here. But if you calculate it and you find you maybe 15, then we can do 15,000. And then the length of elastic, we leave it as per that. So you can also save this. You can save it for you to be able to, you can save it for you to be able to retrieve it tomorrow. So the lecture, and then you can go to the box, and then you can do demonstration. You can do demonstration. So then you can now put this as a 5x4 box culvert. So you save it. Now the loads. Here you have to define the loads. We are using Eurocode or BS. So for Eurocode, you define it. And then here is where you define the self-weight of the density. I told you to know the density of soil. Maybe for this one, the weight density, they are doing, I think this is for pavement. Then there is soil, there is pavement, there is self-weight already given. We can do the 23. Then for soil, we can do our 20. But definitely you have to go as per submerged. They are using 10. For now, we can do the default of 10. And then the angle, internal friction, therefore 35, I can leave it at 30. And then now our underground, ground level, you really need to know the groundwater level. Here we can leave it at 0. So after you have done all that, the shrinkage parameter has been given and the thermal coefficient has been given. So now that is what you know, which is already there. So we can save this. And after saving, I think we can now say OK. And there you are. So I can give you the different colors if I want, random color. So I'm able to have my box culvert already generated. Then I can now save this as a box culvert 3D. So my 3D model of box culvert is already been done. That is how easy you can do that. You can view top. This is now how Midas does this thing. But if you look at what had given you, it is flared. It is flared at 45, depending on the feed. This one is going straight. So when it is flared now, you can go ahead and modify. You get it? So this one, you have done the model. That is one thing you need to know. The next stage now you will be moving to would be now to do more the loading you have done. You can check the loading here. You can check your loading. You can check the different loading. This is your loading. And then I can check the dead load with water pressure. You know, it has a field, so it gives you all that. Then if you look at the lateral pressure, you will also get lateral pressure already given to you. So definitely the whole thing is done for you. Once you can, that is the benefit or the advantage of using what? Now using the wizard. So this is how the whole thing, then you can, and this is display and you can turn display. This is basically what you can do with the modeling. The next stage will be analysis, and then the third stage will be doing what? Doing